Well, there we go. Hello again. Today is Monday, the 29th of October, 2012. Anyways, going back to the pupil. So the doctor drops the drops in your eyes to look inside of it. He takes a big magnifying glass and he gets really close to your face, like almost uncomfortable close, and he looks inside your eyeball, right? What he does is that he's looking inside the back wall of the eyeball that connects to the brain, the optic nerve. Like for me, on one of my eyes, I have a birthmark kind of on the back of my eyeball, but near the optic nerve, and it's a little mark. So what happens is that if that ever spreads, if it gets bigger, then it might blind me. So for the rest of my life, I have to make sure I go to the doctor every year to make sure it doesn't get bigger like cancer. Okay? If it gets bigger, then it might cut off the optic nerve that goes to the brain. It's just one eye. You can't really get rid. It's like a mole. It's like having a mole on your arm or something. You just have to watch it all the time. You know, you can't. No, don't do that. So I don't know. But my whole point is they use dilations to look in your eye to make sure it's okay. When they do LASIK surgery, they drop the drops in, they make the eye bigger, all fuzzy, so the eyeball doesn't move around a lot. Dilation also is used on a television screen, right? When you have widescreen, and when you watch a DVD, widescreen and full screen. When a movie is made, they shoot it in 16:9 format or 4:3 format. I don't know if you've seen that on the television screen. No. That means that the size and the image. So, like for example, like the projector, when it turns on, the light turns on and it shoots the image to the screen. So the bigger the screen, the bigger the image, right?
So when they use a magnifying glass up to your eyes, that's a little blue light.
Yes, it's like they're shining inside the eye.
Yeah, I believe so.
Yeah, it hurts. It kind of burns a little bit. But my whole point is dilations, you use that all the time with projections and television screens and stuff, right? So like TVs are now getting smaller and smaller and flatter and flatter. Back in the day, televisions were like giant. They were very wide and very, very heavy. What it was is that the electricity would turn on, the signal will come on, right, in the back of the TV, and the light will shine the image onto the screen. Now, right, to the projector. Now, everything is so high tech that it just shows right. It shows right on the screen in true life, in real time, in real life, right? So, like when you watch a movie or whatever, the pixels, high definition. All that means is they're able to squeeze the little pixels into a smaller space. That's why the colors are so vivid and so. Like the best TVs. If you go to Best Buy next time, pick the most expensive television. Look at the color black. The darker that color, the better the TV. True story. Because it's the hardest color to make perfect, I think. So like the cheap TVs have like a really poor black. It doesn't look really black. It looks kind of gray. It looks navy. But the best TVs have the best black color. So whenever you buy a TV, that's what we look for. Okay? Now, going back to dilations, ladies. A dilation is very simple. Just like what we talked about, a dilation is an image. It's a shape. It's an image that is produced by a reduction, R-E-D-U-C-T-I-O-N, or an enlargement. Just like on a photocopy machine, you can make the size bigger or smaller. Remember, the size changes, but the shape does not. On the STAR test, you'll probably have 5 to 7 of these questions. Dilations is a really big topic in 8th grade. You did it in 5th grade, 6th grade, 7th grade. You did. I promise. But 8th grade is the last time you'll have it officially. Skip a year, you'll have it again in geometry in 10th grade. Okay, sir? I think it's pretty easy. I'll show you how to do it. It's really easy. So, a reduction and enlargement. Now, the hard topic about the hard part about this one is that the word scale factor. This is where it gets confusing. Just like when you step on a scale to weigh yourself, right? It tells you how much you weigh. When you take a shape, you're pretty much taking the shape and you're weighing it. You're putting it on the scale. And the scale factor tells you how big or how small the shape is. Okay, Anthony? So here, the scale factor is the ratio. The first blank is R-A-T-I-O, ratio. Daniel? that is used to reduce or enlarge the shapes. Alright, this part is the hardest part. The number is multiplied always by the points. We'll work on this. Which one? Enlargement, yes, to make bigger. Reduce is to make smaller. Just like if you, let's say you weigh, let's say 400 pounds, right? And you lose weight, are you still the same body?
No. Yeah.
Well, I mean, you are the same person, but it's just smaller, right? These things are smaller. Just like a shape, the shape is just getting bigger or smaller. A square is still a square. It's getting bigger or smaller. Okay? Diagonal? It's not doing that. Hold on. Let's talk about reduction right here. They will always tell you what the scale factor is. They'll say the scale factor is, well, for example, how do you know if it's getting smaller? Well, it tells you if the percent is less than 100 and the decimal is less than 1.0. Right. Here's how we know. If I gave you $1, how many pennies is that?
100.
100 pennies, right? A full dollar, $1 is 100 pennies. If I go to the copy machine and make a copy of this paper, what percent is this? I want the exact same paper. 100%. So every time I go make a copy, this is 100% of the image, right? Well, if it's a reduction, the percent is less than 100. And this is less than 1.0 or less than $1. So if you have, let's say 0.5, 0.5. What percent is that?
50%.
50%. 50% or
Or half.
half. 1/2. These are all the same. That means that the paper goes from whole to half the size. Reduction. Whole, half. Okay. What happens if it's 1/4?
It's a quarter.
1/4.
0.25.
0.25 or
25%.
25%.
25%.
That means that, oh sorry, this should be 0.25. That means that if I take the paper again, half becomes a quarter, that's a quarter page. So whenever you see a reduction, it's always less than 100% or less than $1 in your decimals. What's the opposite? Enlargement. Right. So just like the projector, I turn the projector on, and then that light turns on, and it beams that the size, the big screen here. Same thing. The percent is more than 100%, and the decimal is more than 1.0. Now, what does that mean? Very simple. Let's pretend I talk about the word twice. Twice. Twice translated to a math number. 2 times, right? 2 times, or what percent? 200%. What decimal? How much money? How much money?
$2.
$2 or 2.0? 2.0. That is twice as big. If I take the paper and I say I need 2 of the same, so I take this paper and this paper, 100%, 200%. Just twice as big. Okay? What happens if I have 3/2? So it's a fraction, but if you look at it, then it's an improper fraction.
Wait, hang on, I have a chart.
3/2, 1.5 or 1.5, right? 3/2 is 1.5 or 150%. It's like having $1.50. I have $1. Why don't you write anything down? Okay, $1.50, $1.50. So if I take this paper and half of it, that's 150%. Right? 200, 150, 100. Yes.
So enlargement would be like a nice poster.
Yes, because it starts with a small picture and you blow it up. Or the camera projection, small camera makes it really big. Or if I take a picture and I make it bigger by double tapping on something, right? So it tells you the steps here. This is the last part and we're done. You will be given a graph, and you're going to find the points. If the scale factor is less than 1, reduction or enlargement? Makes smaller, right? But if it's greater than 1, enlargement. Enlarge. The hardest thing to remember is this part right here. This is the number one question. How to work these problems out. You multiply each point by the scale factor. The scale factor tells you, write this down, new over old. And we'll discuss that. New over old. New over old. I'm going to work some of these out with you. You have 6 problems to do tonight. 6 problems to do. This is a very confusing topic, but I want to make sure that everything that we do makes sense here. So let's do some of these together. I'm going to zoom in into the first one, number 1 here. Number 1. As you can see here, it tells you the scale factor, correct? I'm going to draw it out here. The scale factor for number 1, is 3. The scale factor is 3. What percent, just keep it, what percent is 3? 3, how much? 300% or how much money? $3, 3.0. This is 300%. So when you draw out the picture, it's going to be 3 times big. Now, how do I know? Very simple. This is what you do. See this 3? See these, the A, B, and C? So these are the old points. Graph the old points. 1, 1. 1, 3. 3, 1. There's my old point right here. Picture right there. How do I know what's the new points? What operation do I do? I multiply A prime. What's new A? How do I know? What's 3 times 1? 3. The first point is 3. 3. How do I get that? I multiplied by 3. What's B prime? 1 times 3 and 3 times 3. The new B is 3, 9. I'm just multiplying. This is not hard. And then C, new C, C prime. 3 times 3 and 3 times 1, 9, 3. Those are my new points. All I did was I multiplied it by the scale factor. When I graph that, it's still a triangle, but now it's going to be 3 times bigger. 3, 9, 9, 3. If you notice here, when you graph it out, there's my new. See how old, new. Okay? So you're going to be graphing it out. So on this one, let's do numbers 2 and 4 on the top only. 2 and 4. Calm down there. 2 and 4. Go down to the bottom. Do you notice that there's something missing? Oh, yeah. All right, keep this in mind. New over old. On 5, 6, 7, and 8, new over old. For example, let's do number 5 really quickly. Look at number 5. How do I know if it's an enlargement or a reduction? The little sign, right? They get smaller or larger? Smaller, right? Look, it went from here to here. It got smaller. I know that because of the little line. So I know that this number 5 is it reduced. Very easy. New over old. Tell me on letter P, as in Paul, what the point was for P, the new P. Let's go. -1. New P, new point. -1, 2, right? -1, +2. Make it a fraction. What's old P? Where did it come from?
Negative.
Negative,
Two.
negative 2, and 4. Look at your fraction. What's 1 divided by 2?
Times 2. Times 1.
What's 1 over 2 reduced?
50.
50%, right? Or 1/2? Scale factor is 1/2. What's 2 over 4 reduced?
So on those 4, we're just looking for the scale.
Just pick one point and go. So how do I know this is 2 over 4? 2 divided by 4 is 1/2. So did it shrink? It did. By 50%. I don't know.
Are we doing
So you're going to do numbers 6 and 8 on the front. 6 and 8.
And off on.
No, not on the back. I don't want to do all of it. On the back page, just do numbers 1 and 2 only.
Oh, wait.
So, see where it says scale factor of 2? What do you have to do with all the multiplying? You're doubling everything, right? All the points get doubled. What happens to all these points right here?
Reduce.
Reduced by what?
1/2.
What are we doing the front?
Half. 50.
All of them, right? All of them.
Alright, when we come back tomorrow, make sure you bring your homework back. And makeup quizzes, anything else? You can go. Goodbye. Good morning. Goodbye. Afternoon. Goodbye.
Just kidding.
Goodbye, YouTube.
Alright.
Don't say goodbye, YouTube. No shout outs? No shout outs?